Students, today we will be taking up the topic of equivalent decimals. Now, as we have read in equivalent fractions, that equivalent fractions are those fractions that have the same value. Similar is in the case of equivalent decimals. Decimals that have the same value are called equivalent decimals. So, now 7 by 10, 7 parts out of 10. In the decimal form, you can represent it as 0.7. This we have learned in earlier videos. Now, if I find the equivalent of the fraction 7 by 10, that will be 7 into 10 by 10 into 10. That is equal to 70 upon 100. Okay. This 70 by 100 I can write as 0.70. Here there are two zeros, therefore I will place decimal after the two digits from the right. Similarly, 70 by 100 can also be written as 700 by 1000, where I multiply denominator and the numerator both by 10. So it is also equal to 0.700. That means 7/10 is equal to 70 hundredths, which is equal to 700 thousandths. So, this shows that writing 0 on the right hand end of a decimal number does not change its value. Therefore, in the similar manner 1.8, you can write 1.8 as 1.80. or 1.800. These are all equivalent decimals. Similarly, if I take another example, 45.21, you can write 45.21 as 45.210, or you can write 45.21 as 45.2100. Thus, the 0 on the right side of the decimal, they does not change the value. But if you will write 0 here, that means 0.7 is not equal to 0.07. Both have different meanings. This means 7 by 10 and this means 7 by 100. That means this is 7/10 and this is 7/100. So they both are not equal in value. So decimals that have the same value, they are called equivalent decimal. Let us move to the another topic. The next one is like decimals and unlike decimal. So decimals having the same number of decimal places. The decimal places are the number of digits after the decimal point. So decimal having the same number of decimal places are called like decimal. Like, for example, if I take 2.5, 0.8, 9.1, they all have one decimal place. That means after the point there is one digit. So these three digits or decimal digits are called like decimals. Similarly, 1.21, 35.83 or 0.06, they have two digits after the decimal point. This is the decimal point, they have two digits. That means they all have two decimal places. So they are all like decimals. Similarly, if I take another example, that is 135.008, 0.475 or 1.105. These have three digits after the decimal points, or they have three decimal places, therefore they are like decimals. Similarly, decimals having different number of decimal places, they are called unlike decimals. Now here 2.5, 1.21, 135.008, they are examples of unlike decimals, because this have only one decimal place, this is two decimal place, and this number have three decimal places. Now we can change from unlike decimals to like decimals, as was in the case of fractions, where we changed unlike fractions to like fractions. Similarly, we can change from unlike decimals to like decimals. How? Let us take an example. Now, given are the three numbers with different decimal places. We will change them to like decimals by finding their equivalent decimals. 4.8 means 48 by 10. Similarly, 2.25 means 225 by 100, and 0.893 means 893 by 1000. Now we know that the highest denominator here is 1000. I can change 100 to 1000 by multiplying it by 10. That means I will multiply the denominator and the numerator by 10. Similarly, I can change 10 into 1000 by multiplying the denominator and the numerator by 100. So this will be equal to 4800 by 1000. This will be 2250, 2250 by 1000, and this is equal to similar 893 by 1000. In the decimal form, this can be written as 4.800. This in the decimal form will be 2.250, and this will be same as the original number 0.893. So these are the like decimals now. That means 4.800, 2.250 and 0.893 are the like decimals, as they all have 3 decimal places. And as I told you that writing zeros at the right hand of the decimal points does not change the value of the decimals. Therefore, to change unlike decimals to like decimals, we can simply place zeros with the maximum number of the decimal places. Now let us take one example, that is convert these unlike decimals to like decimals. We have to change the given unlike decimals to like decimals. The process is very easy. Just count the number of decimal point. Here it is 1 decimal point. Here there are 2 decimal points in decimal places, and here there are 3 decimal places. We will see the maximum number of decimal places, and we will put the number of zeros that are required to complete this 1 decimal place to 3 decimal place. So if I put 2 zeros, this will be up to 3 decimal place. Similarly, 7.830 and similarly 12.040. So all have now 3 decimal places, and they are converted to the like decimals. Let us take one more example. Suppose I have to convert 14.9, 275.09 and 2.7256 to like decimals. These are unlike decimals. Here there are 1 decimal place, here there is 2 decimal place, and there are 4 decimal places. So we see that the maximum number of decimal places is 4. So we will change the 1 decimal places to 4 decimal places by placing the number of zeros to the right of the 9. So here 3 zeros will complete my decimal place to 4 decimal place. Similarly, 275.09, there are 2 decimal places. If I place 2 zeros, they will be 4 decimal places. And this is 7256 already, that is having 4 decimal places. So now these 3 numbers are like decimals. Hope you have understood this concept. So moving on to the next one. While comparing and ordering decimal, we will follow the same rule as we used to follow while comparing the natural or the counting numbers. So suppose if I have to compare two numbers 52 and 48. First I will count the number of digits. If the number of digits are same, then I will move to the extreme left corner and find the digit. Now here 5 we know is greater than 4. Therefore 52 is greater than 48. In another example, let me take 376 and 359. The number of digits are same, therefore I will look for the digit at the extreme left. Now they are both same. What will I do? I will move on to the next digit. Now I know that 7 is greater than 5, therefore 376 is greater than 359. So, similar manner we will compare and order the decimals. So, let us take an example. If I have to compare 0.63, 0.24 and 0.6, the very first step is that I will change all of them to the like decimals. That means decimals having same decimal places. Okay. So here we see these have 2 decimal places. Similarly, 0.24 also has 2 decimal places, but 0.6 here has 1 decimal place. So I will put a 0 to convert it into 2 decimal places. Now I will compare the decimals. So while comparing the decimals, we will start from the ones digit. So if I write them according to their place values, this is ones, this is tenths, this is hundreds. So one on another, if I write them and I compare them, the ones digit here is 0. So I will move to the next number. So here we know these two numbers are 6 and 2 is the least number. Therefore 0.24 is less than both 0.60 and 0.63. Now here both are having 6 in their tenths. So I will move on to the next number, that is the hundreds. So I know that 0 is less than 3. Therefore 0.60 will be next in the list, that is least, or that is smaller than 0.63. So we see that these numbers we have written in the ascending order, 0.24 being least, then 0.60, then 0.63 is the greatest decimal here. Let us take another example. Suppose I have to arrange 12.113, 12.114 and 21.311 in decreasing order. Okay. We have to arrange them in the decreasing order. This is the decimal point, this is ones, this is tens, this is tenths, this is hundreds, and this is thousands place. So starting from the extreme left corner, we see 2 is the greatest one. That means 21.311 is the greatest number. So now in the list we have both of these two numbers, that is 12.113 and 12.114. So we will compare them. We will move next to the ones. We see this is both having 2, then to the next both having 1, to the next digit both having 1. So again to the next we see this is 3, 3 is less than 4. That means 12.114 is greater than 12.113. So next in the list is 12.114. While we are moving to the decreasing order, that is this was the greatest number, and 12.113 being the least number. So we will place them accordingly to complete our decreasing order. Hope all the topics are clear to you. If you have any doubt, please write down in comments and do like and share my videos. For more maths videos, please subscribe to the channel. Thank you for watching. Take care. Bye.